Yes, that's right. Thank you.
Hi.
How are you?
Hi. I'm good, thank you. How are you?
Fine.
Well, it's Sunday, so we are experiencing Sunday as well,
Laziness.
Yeah, sure. But we hope that most of our viewers will see us after the after the actual stream. And right now, I'm giving you this stream to talk about using async and await in Flutter.
Yes, thank you. Thank you for inviting me. It's an honor to be here. I hope everything was fine before me. I tried to watch a little bit, and you cannot top that last talk, of course, but I'll try my best. Yeah, so today I'll talk to you about practical async await in Flutter, and I'll talk about myself very briefly, and then I'll go into it. So I'm from Turkey, by the way, not very far from you. I wish there wasn't COVID so we could meet in person. I would be interested in coming over. But yes, so let's start. So I'm from Turkey. I studied here and then went to United States for my PhD. And I got to be an intern at Google for 3 months where I met Dart before it was released. And I got to play with it for a long time. I really liked it. Especially I liked the async await things in it. JavaScript didn't have, promises weren't very popular back then. Async await wasn't heard of. So I really liked it in Dart before that. And after I graduated, I came back to Turkey, to Izmir. I'm teaching at a university here as a faculty member, Izmir University of Economics, in the engineering school. I'm teaching mobile application development and game development in my courses. I teach Flutter and React Native in my mobile app course. And last year, I founded a company where we are developing some Flutter projects also. So that's my background. But yeah, if you're ever in Turkey, in Izmir, feel free to ping me. I'd love to show you around. Okay, so because of my profession, right, since I'm teaching at a university, I see a lot of people who are trying to learn Flutter. I'm teaching them. And also, I try to be active in Stack Overflow. Something that I see often is people say, oh, I want to learn Flutter. It's nice. It looks good. And then they skip on learning async await properly. So they glance on it. They see, oh, futures, async await. They just save the day. And then, they don't know it very, very well. And then they say Flutter is hard. They get all kinds of weird bugs. Because you get to use it early on, and you have to use it, async await futures. And if you don't learn it properly, then you'll have a lot of bad time. So you see code like this all the time: await, async, future, whatever. We don't teach JavaScript, by the way, in my course, but there are other courses. So, I'm sorry, I'm distracted by it. Maybe I should answer later. Yeah. So what's all this future async await stuff, and how should we use them in practice? Is the question that I'll try to answer today. But yeah, in my React Native course, I teach some JavaScript. In my React Native part of the course, I teach some JavaScript. In the Flutter part of the course, I teach some Dart. But I leave it to the students to figure most of it out. I just give the basics. Yeah, feel free to ask questions whenever. And so I said that you early on meet async await and futures. So I personally, found it through the file class. I was trying to open some files, write some things in files, but I was opening the file, and then when I tried to read, I was getting an error because the file wasn't open yet, actually. It was returning me a future. I wasn't dealing with it properly. I wasn't awaiting on it. So the file reading stuff should come after the file was properly opened. But I wasn't waiting for it to be opened. It was giving me a future not to make the main thread wait. It took some time for me to realize what's going on there, but with some Stack Overflow answers, Günther especially, you can see him on Stack Overflow, he was very helpful with that. So I figured it out. But whenever you're trying to do something in Dart and Flutter that takes some time, you have to deal with these futures and async await, and you have to understand it to write, bug-free code, basically. And when you're, of course, doing HTTP, there's some delay, right? You request, the response comes later. There has to be some asynchrony there. And even when you're showing a dialog, right? You say, okay, let me show a dialog in my app, and the dialog asks something. it takes some time for the user to answer. When the user hits yes or no, the future completes and my code can go to the next line, knowing that it was yes or it was no in the same function. So this is very powerful, and a lot of people don't think it this way. But when you use show dialog like this, or even navigate to push like this, it's very powerful. Your code makes much more sense rather than let's go to that screen, let's come back to this screen, etc. So if you know these things well, you'll have a lot of good patterns you'll be catching. And early on, you also realize that you can use futures with async await, right? You can use futures. So I talked about futures in the previous slides, and you can use async await with them. Somebody shows you, hey, you could use it like this instead, and then you say, okay, and then you don't properly learn it, and then you get all kinds of weird situations with them. So today, I'll try to motivate some questions and try to answer them as much as possible. So theoretical first. So what are these futures? What are async await? Why do we have them? How do they work? Should I really understand them, or just save the day with Stack Overflow, which I try to answer? You should really understand them. So that's the first part I'll talk about, a little bit theoretical, but then we'll switch to practical. How should I use them? How do I do X? And if you have other questions also, we can add to this practical list. So let's talk about the theoretical part. So these futures are there to help make the most of a single thread. So Flutter is single-threaded. Some people see this as a downside. It's actually a very good thing to have, because multi-threaded code is very error-prone, and people aren't, a lot of people aren't good multi-threaded programmers. So we have a single thread that keeps things much simpler than it could be. But we also have an app that responds very smoothly. So we never block this single thread. We have things that take time, like going to the cloud, getting things, and even going to the file system takes some time. The reason for having these futures is to keep the main thread unblocked, so things that take time come back as events to us in the future when they are completed. So let's motivate it with a real-world example. I developed this example over a bunch of talks, but I kind of like it. So it's like not to spoil a date, somebody told in one talk. So let's say you went to the mall with your friends are sitting, and you want to go pick a hamburger, right? And nobody likes to wait is the title. So you're going to go and ask, hey, give me a hamburger, please. Here's the money. And they say, wait 10 minutes, please. So what do you do at that point when they tell you to wait 10 minutes? You probably, of course, bring up your cell phone, play with it. But what about your friends? They will be sad when they are sitting there and you're chained to this place, waiting for 10 minutes for your hamburger, right? Your date is probably spoiled. So this is like in code, this is like you have an event handler, and hamburger is equal to wait for hamburger. So this is a synchronous line-by-line execution. Execution goes into this wait for hamburger, and there's maybe a for loop or something that's not releasing the execution back here. This function is not returning. So as a result, you cannot go to this, eat hamburger, or you cannot go to, talk to your friend. Those kinds of lines of code you cannot go to, right? This is the example, and this is when your UI is frozen and you're moving the window around, painting the screen. Sometimes I'm sure everybody had that. So we don't want this. We don't want to make the UI thread wait. Instead, what I could do is some restaurants give you this pager, this little thing that buzzes when your hamburger is ready. Normally, it's not lit up, and then they give it to you. You go back to your desk, and then when it's ready, it lights up, and then you go pick your hamburger. This is the perfect analogy to a future object. So they give you a future instead of the actual hamburger. And then you go back to your table, and then everybody is happy. You eat your food, and then when your hamburger is ready, they press a button, your pager buzzes, lights up, you go pick the hamburger really quickly, you eat it with your friends, everybody is happy. So we want to have this kind of a thing going on in our code. And if we think of it like code, so earlier in our event handler, as you remember, it was a synchronous wait for hamburger function that wasn't releasing the execution back. Here we have an ask for hamburger that gives us a future object, this pager. And then with that pager, we can do things like when that pager lights up, execute this function. Not right now, but when the pager lights up, execute the function. And exactly the same thing is over here. So this is the syntactic sugar async await version of it. Ask for hamburger still returns as a future, but this await keyword magically gets the hamburger out of it, and then we eat it. So how does this happen? It actually this code is, above code is executed, but your code looks like this. Under the hood, the above code is executing. But this, to the user, to the programmer, it lets you write code like a synchronous version of it. This is very powerful. So actually over here, the execution is released. It can go do other things like refresh the screen. And then when the hamburger comes in, then this line continues to give you the hamburger. So I'll be talking about that a little more. But basically, this is what's going on. You're getting the pager, and then when the pager buzzes, you're doing something else in the future. Right? Yeah. So we get the future. To the future object, we attach a function with then. And in here, everything is happening in this one line. And then this code is not executing, right? Eat hamburger part is not executing. And your function actually returns. And similarly here, this code is not executing. It remembers that we were here. This white arrow is that. So it remembers that we had a future. When the future completes, we'll continue here. It remembers that we have an await. When this future completes, the await will let the execution move here, the function to progress. But the execution itself, the thread itself, actually went outside of this function, which is really powerful. We didn't hold the thread hostage. Right? And when the hamburger comes in, your pager buzzes, your future completes, then your future remembered that there was a white arrow earlier here. It remembered that we had this thing, function next to it, and when it's complete, it actually executes the function. You eat the hamburger. Okay? So top and bottom are equivalent code, and that's how it executes. Part of it executes in the future, in the above one, in the below one, the rest executes in the future. But your function actually was able to return immediately because this returns a future, this just returns a void. Nobody uses them. Okay, so that was a real life analogy that I tried to give, but when you're explaining it like this, it's always hand wavy. Oh, imagine that this is happening later, etc. So now I want to give a very concrete representation of what's going on in the computer. Okay, so no hand waving here. If anything is left out, feel free to ask. I want to make sure that everything is covered as much as possible. So you have a processor, right? This is how we learned how to code. There's some code. And line by line, that code is executed. That's how they taught us how to write code, right? How code executes. This is synchronous execution. This is your thread. There's one thread in Flutter, like I said, one processor, one thread. And this thread moves on line by line, executes. The thing to notice here is that before this line is executed, completed, I cannot go to the next line, right? So if one of these lines holds the thread hostage, the rest cannot continue, like the earlier hamburger example. Okay, so let's, we have it in our head. This is how it is in Flutter. We have an event loop, also in JavaScript. You can think of it like that. We have in our main thread, we have an event loop that keeps, it's like while true, keeps turning. Okay, and our event loop, for a bunch of reasons, calls sometimes our functions. For example, a button is pressed, our function is called in the event loop. Event loop keeps turning. When I press the button, event loop calls that function, right? And then there are other functions that the event loop calls also, right? Blocking one will prevent others, as you can imagine. So event loop is executing. I press the button, let's say, my function got executed. So as you can see, my thread is here. It cannot go over here without me letting it go. Okay, and it returns. And then there is another function that refreshes the screen that comes from the framework. It goes to that function, refreshes the screen. So what does this mean? So for example, I pressed it, and I moved my finger below, the contents should scroll down, right? This is the function that redraws the screen, so the contents move down, and I feel like, oh, it's responding to my finger. So it has to go into this function like 60 times per second. Okay? So this is the regular execution. But then sometimes in my function, I start like a large download or something that takes time, keep the thread hostage here if I can do that. Then the thread cannot go to the function that refreshes the screen. It's not responding. My finger touches it, it's not moving. And then, Android says, this is not responding. Should I kill it? Even though it's actually doing something. So actually, we cannot have this in Flutter. If you do like a while true, perhaps you could. But with regular usage, like downloads and things like that, you cannot have this. They did it so that they created the standard library so that everything returns you a future if it takes time. But in some other frameworks, you can do that. So you don't want to do that. Instead, you want to you don't want to be chained here. You want to get a future. You want to get a pager that will be buzzed sometime in the future, and you can continue your work here, right? This pager, as you can see, this line 5 that I have here, after the download finishes, we give that as a separate function to this pager. When things are done, when download is completed, execute that function with that line that uses that download result, okay? So it's a separate function. And then line 4 executed, and we let the thread go, everything is fine, and we have a now separate function that did not execute yet. It will be executed when download is complete, and the pager, the future object, knows about that, okay? And then we continue our event loop. We are happy that we can refresh the page, right? Everything is scrolling smoothly, even though the download is happening in the background. The framework is taking care of that for us. We don't care about it. When it's complete, it's going to let us know. And we move on. And then there's actually another function that continues unfinished tasks that I wasn't showing you earlier. So whenever this buzzes, that function will get, call this function that to execute when download is complete. So let's see that. So let's say as the event loop is progressing, download is complete, the future says, I'm complete. The buzzer buzzes. And then the thread is moving on. It doesn't immediately go there. It just continues. It goes to the function that continues unfinished tasks. And then it looks at the completed futures. It says, oh, this future is complete. The download is there. Hey, dear future, where is your function to execute when you're complete? It says, yeah, here it is. They gave me when they were creating it. And then we say, okay, let's go handle that. Use the download properly. And then let's go back here. This was quick. So that we can, again, go to the function that refreshes the screen, right? So my screen is still scrolling. Okay, so this is how it happens. We are given a future. That future is attached to a function. And our event loop, when that future is done, in this special function that continues unfinished tasks, it goes to the handler of that future, that function that we attached to that future. So this way, asynchronously, we were able to do other things. And when that was complete, when we were ready, we were able to go back to it and continue what we were doing there. Okay. So here's our function. Remember, in some frameworks, like I said, you can keep the thread hostage, and the main, the app seems unresponsive. This happens with downloads, but this can also happen with things like reading a file. Reading a file also takes time, even though it doesn't take as much time as doing a large download. It does take some time to read a file. And especially, I believe, when our Android phones got older and they got slower, Google Maps especially gets jumpy, I believe it's doing some file things or something that takes time that's not asynchronous. So the thing is, this event loop, if it takes t time, I'm just making numbers up, but this is close to correct. Let's say 60 frames per second, t amount of time it should take the event loop. Reading a file can sometimes take 10t amount of time. So that means that 10 frames being dropped, your app appearing jumpy when you're scrolling, your app stuttering. So this doesn't happen in Flutter, like I said, because everything is returning a future. Everything that takes a time, like reading a file, returns you a future that you can await on. Okay, so these futures or promises in JavaScript, if you're not going to wait for something, you need something like that, or an I owe you money, or I will give you this kind of a token you need, which is these futures and promises. Let's say the burger shop gives you a piece of paper. They give you a pager, or somebody gives you a box. They give you the box right now, but they say that this box will contain your answer. It will open by itself when it's time. Do not try to open it yourself at the moment. Okay, so it's like that. A future object is like that. They give you a box, but you're not allowed to open it yet. We see questions on Stack Overflow all the time. Hey, Git gave me a future. How do I get it out of the future? You cannot. It will happen in the future, sometime later. Sometime later, you are able to get it, so you'll know how to work with the future object. You need to learn. Okay, so this future object is like a middleman for callback functions. Right, there is a producer, there's a consumer. Producer is the HTTP library. It downloads something, gives it to you. Consumer is your code, and when you say, okay, download this file, it says here is the future. I'll give you the result through it once I'm done. So immediately it gives you something, and then you say, okay, I'll know what to do when you're done. It works on downloading the file, creating the result, and in the meantime, you can do other things like scrolling the screen. And then when the download finishes, it says, I'm done, here's the result. You say, okay, great, I had attached a code to it. It will be executed, I'll use the result there. So this is kind of a broker between callback, between two entities. Rather than passing around functions, we pass around these features, which is a standard thing. Functions wouldn't be standard. You would have to know too much about the two sides. This is like decoupling the two sides, consumer and producer. So here on the left is regular synchronous code, right? Int get val returns 1, void main calls it, gets that result, prints it. Very simple as I could. Piece of code. On the right is the asynchronous version of it, right? So get val returns me a future, and then I need something that gives me a future. Future.value gives me a future. It could be an HTTP request, something like that. As you can see, I am returning the future object. I'm creating the future object myself. I'm returning it. And then in here, I'm calling that get val. It gives me the future object. What do I do with the future object? It is a then method. I say that then, and I attach a function to it, which will be executed in the future. So this is the bare minimum usage of futures without any async await, without anything like that. Similarly, we have a stream class. This is very often used in the block pattern, which you had a talk today earlier. Similarly, we have a producer and a consumer, but the producer creates multiple results. Here's a result, here's another result, and your attached function keep executing. Okay. For example, you can get the stream of the keyboard. Every time the user presses a button, your stream gives you one more entity. So similarly, the sync and async versions of things. So stream is a feature for multiple objects. So what's a multiple object thing? We have an iterable. We have a list, which is a iterable. And if I have an iterable, I can do a for loop on it, right? If I have a list like this, I can do a for loop, for in loop, to print every element. If I have a stream, what do I need to do? Similar to the future. Now, it doesn't have a then method. It has a listen method. I attach a listen method to it, listen object function to it, and that function is executed every time an entity comes. So these are very bare usages of them, as I said. I'll show you better ones coming up. So, okay, so this is the future object, stream object, and they have so many methods, so many usages, etc. But I want to get to async await, the better way of using, easy way of using them. Async await makes things easier. So future is great, but writing sync code is easier. So if you look here, the code on the left, the synchronous code, looks much cleaner than the code on the right, much less error prone and much easier to understand. So it's hard to write async code if you don't have something like async await. But Dart language and standard library have async support, which makes writing async code very pleasant, which I'll cover here, but there is other things, sync star, async star, yield, etc. if you want to create streams with functions, generators. But let's just cover async await here. Okay, so remember the earlier future example with the sync and the async. The red stuff is the new stuff. So remember we were returning a future and they were using this then. So in the center code, as you can see, this code on the center looks very much like the code on the left, and not complicated like the code on the right. But the only additions are this future return, asyncs, and the await keyword. But as you can see, it's line by line. We're not introducing a new function, new inner function. This is very powerful. You can have for loops, try catches. You can have different branches. One of them has an await, one of them doesn't, which you couldn't do with this. So let's look closely here. As you can see, the first one looks similar. My get val returns a future. It has an async keyword here. This async keyword lets me return the value that the future will send over. Instead of creating a future myself, instead of returning a future myself, I am able to return the value of that future. Okay. So let's say before this line, I did some things that took time, and then I can say, okay, I'm done, return 1. And the future that we returned over there, this 1 would be sent over to the then method. Okay. So this async keyword lets you return the value that and wraps it into a future for you. And if you have an async keyword, you can also use await keyword in your function. You can change your main to async like that. And this await similarly lets you use this future like synchronous code. it actually waits here. It lets the execution continue otherwise. And when this future completes, it completes this line and then gives the one that you gave in the future to this val and then prints that. Okay, so this looks very much like synchronous code, sequential code, but it's actually this one on the right. Okay, so this is the best of both worlds, and you should use that rather than dealing with futures bare directly. Okay, so the whole point is how do we continue after a time-consuming task, right? In the synchronous code, you go to the next line to continue. You know, wait for your hamburger. You got your hamburger. You continue in the next line, which is easier to program. Very bad for the interactivity because you are actually pausing the UI thread. In the async version, we are creating a separate function. These lines at the end become a separate function, and you're giving that function to the system. Hey, please call this function when that time-consuming task is done. So this blue task starts, and then I attach this as a separate function, and other things go on. And when that is complete, I continue with that separate function. So I'm not in the same function anymore. I cannot do a for loop, if around it. I cannot have local variables, for example, since this is a separate function. You can have closure, of course, but not, you cannot have blocks like if, etc. that are shared. Okay. Async await is the best of the both worlds. So you go to the next line to continue with async await. You put an await here, you go to the next line to continue, but it actually works async like the below, right? That's actually behind the scenes made a separate function for you. And then you can do other things. And when things are done, then you can, that part completes. So this is the best of both worlds. You can code it like sequential synchronous code, but it actually executes like asynchronous code with the future. Right, so next line, async, best of both worlds is the using async await. So never use futures or streams directly unless you have a very good reason. Always strive to use async await. Okay, we talked about futures and single values, and we also talked about multiple values with stream, like the one on the left and the one on the right. We had a stream, and we were saying .listen. And these codes are just one way to create the stream. Of course, you would be given a stream by someone else, like the HTTP library or something like that. So you were able to write a for loop around the list, around the iterable. You are able to write an await for loop around the stream. So this can be a little hard to understand the first time you see it. So somebody gives you a stream of the keyboard. Every time I press a button, stream sends over one value. I can put a for loop around that. So every time I press a button, the for loop, await for loop turns one more time, and it waits for me to press a button. So this is very powerful like that. Every time a byte comes through the network, my for loop continues one more time. The good thing about it is you're still in the same function. You can have local variables. Your state can be in your local variable. Your state can be in your, which line you're at is a part of your state, for example. Otherwise, you would have to store things in fields, etc. Callback function is executed. Let me update my fields. Writing socket programming is very easy like this. Okay. So far I talked about async in Dart, right? How it works, how it is behind the scenes. So what about Flutter, you may want to ask. Of course, if there are any questions, I'm happy to answer, but maybe one more time I'll go over. So this future is, you have one value, regular synchronous value. The asynchronous version of it is a future. This is a future that gives me an int, okay? And the asynchronous version is, you have the future, you say .then, and then you give a function that will execute sometime later, right? And then you have a stream. Like I said, the above code, don't worry about it. This is just one way to create a stream, but you would get that stream through a call to some library usually. And in synchronous code, you can do a for loop around an iterable, print all the items one by one. In the asynchronous world, you can do .listen to a stream, or you can use the await for, like I said. So when you're talking about the future, rather than saying .then to a future and attaching a function to it, instead you can say await before a future. So this getVal returns me a future. I can say await, and the execution will actually return from here, like the example that I showed in the beginning, the hamburger example. And then when this future is complete, when this one is given, then I come back to this line and then continue the rest of this main function. So it actually executes like two separate functions, but I write it as one single function. And for the programmer's purposes, it's like a one single function. You keep all the local variables, the state, try catch, everything you can keep. And having the async keyword forces you to return a future. And I can actually show it very quickly. For example, let's create a int get val return 1, right? So I can have a function like this. I can say convert to async function body. As you can see, when it added async, it also made it return a future. It's wrapping this one around with a future. This is very powerful. Also, the IDE features I will talk about a little bit later. Okay. Similarly with the async, when you have a similar with the stream, when you have a stream, you can do an await for around that stream. Every time a value comes over, you print that, and you wait. Your for loop waits for a new value to arrive. Okay. So this is also very powerful. Okay. So let's try to dive to the practical side of things. This was all theoretical, almost half of the talk. Let's talk about the practice. How should I use them? How do I do X, right? And I'll try to give you some examples. First, again, motivated. But Flutter has async support also. So far what we talked about was Dart, the language Dart. But Flutter also is aware of these async await features. Flutter is all about widgets, right? User interface elements. There are two widgets, Future Builder and Stream Builder, that Flutter provides for us. These directly support asynchronous. You give a future to a future builder, it works with it. Similarly with Stream Builder. You can use that, but if you find it too boilerplatey, too much code, it looks like, you can also handle your own futures and streams. You can use async await yourself, but sometimes there are things to be careful about because of, one is Dart, one is Flutter. Dart doesn't know about Flutter, and Dart functions continue executing even though you went to some other screen. I'll talk about that bug that you can have. And the block pattern that you saw earlier today heavily uses streams. So before using block, make sure you understand streams really well. Practically, you can use them, etc. Because I see a lot of people, they start Flutter, they immediately jump into block because somebody tells them it's the good thing to go with. But they don't know about async await as well as they should, and then they run into all kinds of issues. Okay, so Flutters UI architecture, you may have heard, it's all widgets, right? We have these user interface elements that's like a tree of elements that's getting smaller and smaller on the screen. If you have the data, then you can create this. But if you don't have the data will arrive in the future. What are you going to show to the user, right? You have to show something immediately. You have to it should be responsive, right? The user shouldn't see a frozen screen, white screen, or something like that. So what do you do in the meantime is the question, right? If you don't have the data, then you can use the Future Builder widget, just like adding a text on the screen. You can add a Future Builder on the screen and give it a future. You're saying that, okay, I don't have the data yet, I have a future for it. And with that, I will create this future builder that will take care of things for me until the data arrives. When the data arrives, that will use it. So initially, what future builder does is calls the build method that you provide to it, build function that you provide to it. It tells that function, hey, data is not there yet. What should I show? And there you show like a circular progress indicator or whatever you want to show, basically loading. Excuse me. And when the data arrives, when the future completes, then it calls your build method again. So you are able to actually build your UI with the data that is here now, that wasn't there before. Okay, so future builder makes Dart work with async. Stream builder is the same way, but multiple times data arrives. So for example, like on the corner, you can have like a Forex dollar versus euro, something like that. As it changes, let's say you have a stream from the server. As it changes, you see a new thing appear every time another value arrives through the stream. We use this heavily in Firebase. Flutter and Firebase work really well. So you can listen to a Firebase, Firestore path, and then every time somebody writes something there, you see it immediately over here if you use the stream. And here is the code. On the left is the future builder, on the right is the stream builder. So as you can see, this is the build function. This is where we create our user interface. We are creating a column. This is the regular kind of user interface. I could, there's the children. I could put a text here. I can put a container here, etc. These are the regular user interface elements. Similarly, I can put a future builder if I don't have my future, if I don't have my data yet, if I have my future for it. So I need to put that future into a variable in my class, into a field, which I'll talk about later. So don't have a function call here that creates the future over here, and which I'll talk about soon. But we have the future. We are giving the future to the future builder with the future parameter. And we're giving a builder function to the future builder. So this builder function is executed by the future builder a bunch of times. Initially, it executes if there is no error initially, but snapshot has data is false initially. So it executes that with this, and you get to show a circular progress indicator initially. So when this is first created, this part of the code executes, so you show a progress indicator. And sometime later, when the future, if there is an error, it again calls this, and then it says snapshot has error, snapshot.error has the error, so like the try catch. But if actual data arrives, then it calls your function one more time, this inner function, and no error, there is data, so you get to return the actual row with the icon, text, whatever that comes from the snapshot from the future. Okay, so this is how future builder works. Exactly the same thing with stream builder, but the stream gives you multiple data, so this is called multiple times, so you get to create the row multiple times. Only once you show the circle progress indicator. Once you have one data, then new data arrives bit by bit. So the alternative, if you don't want to use this, so yes, this is good, but this can feel a little boilerplatey, right? It's too much code. Where is my code? All these ifs, etc. You may want to handle it yourself. How do you do that? In your init state, this is a pseudocode. In your init state, you can start an asynchronous job, which I'll talk about later. You can do this. You don't have to await on everything. And this is like starting a thread. And your init state has to return immediately. And then it starts this. And this one, and in your build function, since your state variable is null, this didn't execute fully yet. If state is null, you return loading. Okay. And since you started this is waiting on this obtain, let's say HTTP request, something like that. It was awaiting on it, build function executed. When this completes, then you can have your variable R contain the result, and in your set state, you can give it to the state variable, and then your build function can execute one more time, showing the actual data. So this is more or less like future builder. Okay, you can handle your async yourself, awaits and set states following those awaits. Okay, so this can feel a little more cleaner. And if you have multiple things, multiple futures that will be coming up, then this may be cleaner to use rather than a bunch of future builders nested. But there's people all the time run into this issue when they try to do this. You see the set state called after dispose bug, dispose exception. This is happening because your user info widget, this widget, actually moved out of the screen. So it's not there anymore. It's not in the widget tree anymore. But Dart doesn't care. You started this async function, it's going to complete. So when it obtained, it calls set state, but it's not there anymore, so you get this exception. Okay, this is why you get this exception. This can be okay actually, but there are ways to avoid that. But if you don't want to avoid that, sometimes it's also fine. What do I mean by that? So if you want to avoid this exception, you can replace your set state with something like set state if mounted. You can do find replace. And your set state if mounted can be checking the mounted Boolean, which means that am I in the tree or not? And if it's mounted, then call set state for you. So you don't have to do if mounted everywhere. This is easy to do. Or you can have if not mounted return right before your set state after each await. Or you can just ignore this exception because this exception is saying, okay, you want to put something on the screen. You're not on the screen. You cannot do that. It's an exception, but the nice thing is, the function cannot continue. If there were other set states, it cannot continue. It just gets out of here. This is a good thing, actually. This is an exception that function should not continue. This is just like if not mounted return. You just see something in your logs. I think you can sometimes just leave it alone. It's actually helping you not continue by raising this exception. So you have 3 options here. And in some of our apps, we are actually taking this approach sometimes now. And this is the code with the set state if mounted I told to you about earlier. So you just write this function and you find replace all your set states with set state if mounted, and you don't get that exception anymore. But your functions will continue if there are other stuff after that, that will continue. But you avoid that exception easily. Like this is the easiest version of avoiding that because find replace is very easy. Okay, like I said, you can start an async function like a thread. So what do I mean by that? So your init state function, you cannot have it be async. It has to be normal function, sync function, because you're overriding it from the parent class, and Flutter expects it to be a sync function. And you can here call an async init function that you created, which returns a future, which takes some time. But as you can see, we're not doing anything with that future. We're just throwing it away, which is fine. You just get into the event loop like this. It will continue executing, but you don't wait for it, which is fine. This is like spawning a new thread. It works like that, which was the case in our example that I showed earlier. But if you're doing this in an async function, this is likely a bug because you maybe forgot to await on it. Maybe you meant to await on it. For example, when you open a file, you get a future. You assume that file is open. It's very easy, right, to open a file. But no, it takes some time, so it gives you a future. If you don't await on it, you run into issues. So you can, if you want to use the this analysis options file, if you put unawaited futures here, then if you did not await on a future, it will warn you, hey, there is a future here that you didn't wait on, which is very nice because you actually do sometimes forget to wait on futures, creating bugs. Okay. So that unawaited that comes from package pedantic helps you avoid those bugs. There is Ide support. So for example, you created a function start counter. I hope you can see this. And you hit Alt-Enter. It says convert to async function body and then converts. I showed this to you earlier, actually. It puts the async, makes the return value future. Always it has to be future, even if it doesn't return anything, because the person who uses it needs to see that. Otherwise, you have no idea if it's an async function. For example, you have a sync function and you want to await something. It says, oh, you cannot do this. Well, you go there, hit Alt-Enter. It says add async modifier, because of this. And then it does it, and then everything is happy. Similarly, let's say you use the function that gives you a future, some HTTP request or something. You hit Alt-Enter, got this var future. You can say add type annotation. It says, okay, this is a future, so you deal with it. You say, oh, I should have awaited it. I didn't want the future. I wanted the actual result. You hit Alt-Enter again, you get the int. So I play like this. I code like this a lot to figure out what I'm going to be doing. I think this is what I show in this screen. The bottom part is an easy way to deal with functions that return futures. Okay, and earlier, as you remember, the init state, we were saying it has to be sync. It cannot be async. It actually lets you write the newer Dart versions. It wasn't possible earlier, but the newer Dart versions let you change the return value of the function that you're overriding. So this code, when you write it, it doesn't complain in the IDE. But when you run it, it says init state return the future. It shouldn't be an async function, etc., etc. Okay. So your init state, whatever function you're overriding, you shouldn't change it to async. Okay. You should keep the way it is. You should keep it sync if it's sync. But similarly, on the other flip side of the coin, you can make event handlers and such functions async if its return value is void. So for example, this onPressed function, there's a function here which returns a void, which doesn't return anything. It's a void function. You can make it async because the return value became a future. Who cares, right? And you can make it async. You can start up something here. You press the button. After 1 second, it will do something. It's fine. It just works. Okay. So event handlers, these inline functions, you can make them async. You can use await in them. But these overridden functions, init state, etc., did update widget, things like that, you cannot make them async. Your constructors, your build function, you cannot make them async. Also, your validators in forms, you cannot make them async, but there's a way to, there's a little trick that you can do to make it happen. And another suggestion is, if you're using Stream Builder, separate UI code and async code for clarity. That's what I do sometimes. Stream Builder, async builder, like I showed you earlier, there's a lot of ifs in it, and you have to look around, oh, where is my actual UI elements, right? So this is what I do actually. In my build function, I have an inner function, okay? Really build inner function. Dart allows you that. It doesn't get called immediately, so it gets to here. There's a stream builder here. This is all boilerplate as far as I'm concerned. So standard code, boilerplate, it means that it's just standard code, that's filler code. It's not very interesting. So I have the stream, I have the builder, has errors, shows you the error text, has data, calls the really build. Otherwise, calls circles progress indicator. These were switched in the earlier example that I showed you. But nice thing about this is all error checking, boilerplate, dealing with the stream code. This is my actual UI code. So I put it into a really build function. And when I look at this function, where is my UI code? Oh, it's in the really build function. I don't have to look down here. So this is one way to make stream builders, future builders, less boilerplatey, clearer. Okay, so this is one thing that I talked about earlier, no side effects in the build function. What do I mean? So if you have a future builder or a stream builder or anything else in the build function, don't have a function that creates a future here, okay? So what is this code doing? This is a UI build, right? It's trying to create a user interface element, and there's a future builder here. And to it, I'm giving the HTTP call function called result as the future. So these build functions can execute multiple times for a bunch of different reasons. You have an animation in this widget, build function will execute again and again. Something changes on the screen, you press a button, now it's 5, counter is 5, this build function executes again. And every time this build function executes, this HTTP call function executes again, okay? So when the HTTP call function executes, it makes a request to the server. So imagine that in the worst case scenario, if I have an animation here that does 60 times per second builds, right, 60 frames per second, I'm making HTTP calls 60 times a second. I'm trying to do that at least, right? I'm starting these HTTP calls, bombarding my cloud, whatever endpoint I have. My bills will stack up, and people say, oh, Firebase is too expensive. So that happens. I see it all the time. Actually, this code on the left is from Flutter's official videos where Andrew Brogdon teaches Async Await, because, of course, this is easier to show in a small video. But no, you shouldn't do this. If you look at this Stack Overflow question, Remy Rezulé explains it nicely. Maybe we can actually click it. Okay, trying. Oh, okay, I cannot bring it here. So if I did like this, yeah, in the Stack Overflow question, he explains it. He actually asks it himself and explains it nicely. This is the author of Provider. So he explains very nicely why you shouldn't do that, why you should have the stream in a variable and create it in the init state if you can. Okay. So let's go back. Yes. So you shouldn't do this. Instead, what you do is init state is called only once when this UI element appears. It's called only once, and there you do your HTTP call. You remember its future that it returns, and then you give that to here. So what happens every time this is built one more time? Every time it's built again, it's using the same future instance. If we have already received the result, when you build it again with the future instance, your builder function is called with the data. Okay, it doesn't wait for anything anymore. Okay, so this is the way to go. If you're doing anything else in the build function rather than, hey, I have data, let's create the text for it, whatever is for it. Okay, but if you're in your build function, if you see function calls, be very suspicious. They can be doing side effects, and that's something that you don't want. Okay, so since we have a little bit of time, I want to show at least this part. Yes. So let's. Okay. So let me go here. So let's say we have a function that returns a future, for example, another async function. I want to use it in this async function, right? When I call it, I don't see its code. I just say another async func, right? I called it, great. And since I have the analysis options, it underlined it. There's a future here, it said. But if you don't have the analysis options, let's see, delete this because this is how it comes by default. As you can see, it went away. So you're not going to see that. But it's a good idea to add that analysis options function. Okay, so I come here. This is my practical usage of Flutter. I call the function, hey, let's put it into a variable, right? I assume that it's a value, right? I would be wrong if I continue. What I should do is I should also say add type annotation. Oh, it turns me a future, not a value. So then I should await it, undo. Well, maybe val, and then I can do an await here. Then I can say, well, okay, this doesn't return anything apparently. This is a void, so this is good. But let's find another. Let's write another function, maybe. Yes. Yet another. I could have used. Okay. So when I'm calling this yet another async func, I hit alt enter and then says, oops. What's the issue here? For it to wait. Oh yeah, so the same name, that was the issue, sorry. and I can say add type, oh, this is a future, right? Undo, put an await here. Yes, I have my int now, so I can continue, okay? So this is how I work. Whenever I meet a function that I'm calling, I can show dialog. Show dialog returns me what? It doesn't return anything, but if I do like bool, let's say he pressed yes or no. Why is this complaining? Yeah, the same name again, sorry. Add type annotation. Oh, this is returning a future, so I can await on this show dialog, right? And oh, this is returning a boolean, so I can put it inside an if. Something like this. Okay, so you can play with this, and the IDE helps you a lot in understanding what it is returning, what I can do with it, and if you always do the should add type annotation thing, you're not going to run into any bugs, and it will also help you. What can I do with this? What can I do with this? You can do a lot of thinking inside the IDE without actually looking at the documentation. Okay, so that's my talk, and there are some references, some of my talks, and Andrew Brogdon's great videos about Async Await, which I also mentioned earlier. Florian Loisch's talk was the one that made everything work in my head. I really appreciated that talk back in 2015. And happy async programming. I hope you like it. I hope you enjoy it as much as we do. And I have a company that we're developing Flutter applications in, and you can reach me with gazialankus@gmail.com or with the Twitter handle that I have, gazialankus. Yeah, feel free to reach me about anything. Some advice for beginners: touch typing. I always talk about this because I think it's important. If you print out something like this on your wall, and then you look at that instead of looking at your keyboard, you stop looking at your keyboard, and your different fingers are responsible for different keys, so you can type without looking. And make sure you learn your IDE features before you progress for both Android Studio, IntelliJ, or VS Code. There is nice IDE feature articles for Flutter. So thank you. That's all I have.
Thank you very much.
Welcome.
Thank you.
So async and await and all this asynchronous programming is kind of frustrating for beginners because it sounds like it's a hard topic to study, but it's actually not. And especially for those who are still studying in, so to speak, old school university program, which is more about procedural programming and so on. And it was back in the days where the whole concept of developing was based on the paradigm that user actually can wait. But then came mobile phones, then came the app stores with all those competitive applications that are trying to get seconds of your time just to promote itself and so on, when we kind of face the situation where user actually cannot wait and will not wait. And if you make user wait a little bit, you're gonna lose that user. Especially interesting since you mentioned that you are teaching game development as well, right? Mm-hmm. Because game development is kind of full of, mobile game development is full of all these async requests that have to fetch the data, all those pop-ups, all those statistics that are grabbing from different servers. And unless you understand that you should be using asynchronous programming in the particular game, you will not make the game that will keep a gamer's attention. Because in thread-heavy applications, user will not wait for sure. So our dear viewers, please consider that. Now we have a little bit of questions from the chat.
So yeah, in the meantime, maybe I can say, so we're doing game development in Unity, which doesn't have async await like this. It has coroutines, which is a little more difficult to use. And I cannot immediately teach students that because, you know, there's all kinds of boilerplate going around, IEnumerator, etc. They ask why, and they make all kinds of mistakes. So, but without that, it's very difficult to write the code for them. So they keep everything in class variables, etc. They try to keep state like that. It becomes very difficult. So it's a challenge. But I think in Flutter, with async await, it's very easy for newbies once they learn how to use it, compared to like something like Unity, which is a little more complicated to do async await, asynchronous code.
So Jamshid John asks about the difference between then and await.
Yes, no difference at all. As await is in the background, under the hood, it's actually doing a .then for you. So it's actually doing the .then for you. There's no performance difference. There's nothing difference. But if you do await, then you can put a try-catch around it. And you can have multiple awaits. You can have a big try-catch around them. You can catch errors very nicely, very easily. With then, you have to have like a error, I forgot the name, error catching function that you have to put at the end. So with using .then and futures directly is more cumbersome. And you cannot do things like this. For example, you have an if. If it's true, I will do something that takes time. If it's false, I won't do anything that takes time. So you cannot do this with .then. But you can do this with async await. You can put in one branch, you can await. In another branch, you don't await. You do something synchronous. So there are things that are very difficult. Maybe you can do somehow, but very difficult to do with .then. But as far as what's actually happening in the computer goes, they are exactly the same, .then and await.
And what if the future response have to come in a certain time frame? I guess the case would be when the data that you are fetching is getting older, faster than you might fetch it.
So I didn't fully understand. Can you repeat?
So I want to, Jamshid John asks if he wants to wait a future response for a specific amount of time.
So future.delayed creates a future for you that completes after 3 seconds, for example. But if that's the question, yeah, you can just say future.delayed. For example, you want to just for fun make the user wait for 3 seconds. Just say future.delayed, and you get a future that will complete in that many seconds.
Yeah, well, it might be the case when the data you are grabbing from a server might get old in that 3 seconds. So if you wait longer, you don't need it anymore. And how to handle errors, also from Jamshed John.
Yeah, so try-catch works just like it does in synchronous code. The sequential code try-catch works exactly the same in await. You just put a try-catch around it. You don't care that there's an await inside, and it just works.
And it will not block the process, right?
Yeah, no, it's not going to block. So that's the beauty of it. You have a try-catch thing, and then you convert everything to async. It just works the same way, exactly the same way. You can even debug it line by line.
There was also a question by Ilhom, if JavaScript is also taught. I'm not sure about the context.
I was talking about the course that I had, mobile applications course at our university with React Native and Flutter. We spent a couple of weeks talking about both JavaScript and Dart. So that's what he was referring to. I teach some JavaScript there, but I leave it to the students to get better at it.
Okay. Thank you very much. Thank you very much for your time.
Thank you for having me.
Thank you.
Nice talking to you.
Yeah. And have a good day.
You too.